Good day and welcome to our up on board. We are having a numerical question in under 6. Now the question says, for the bar shown below, calculate the reaction produced by the lower support which is in the bar, taking Q to be 200 giganewton per meter. Find also the stresses in the bar. This so from here we can see we have a bar here. We have one end, other end also to be. But this bar, of course, we are told that we should find what expresses as support touches the bottom of the bar end. So we are going to be solving this question. First, we are going to be finding support, then we move to stresses. So first thing you need to note from here is that the sum of upward force in this bar must be equal to, of course, we know that the sum of upward force must be equal to the sum of what? Of downward force. So we are going to be having R1 plus R2 to be equal to what? 5 kilonewtons. To do that, guys are going to have R1, R2 equal to what? 5. Cos is nothing but what? R1, R2 equal to 5,000. Now we can make R1 the subject of the formula here. Say this to be equal to 1, making R1 to be subject of the formula, we are going to have R1 equal to 5,000 minus R2. And similarly, making R2 the subject, R2 is equal to what? 5,001. So this is what we have. So next, I'm going to be drawing the free body diagram of each section. Let me take this to do my section 1 and do my section 2. Now, to draw the free body diagram of section 1, which is nothing but LM, what will I be having? From the question there, I'm having R1 here. Now, at this point, I'm going to be having a force, of course, tensile at this point. But here, I'm having 5 kilonewton, and I'm having R2, which is what? A reaction that is going, that is opposing to 5 kilonewton. So to get the tensile force here, all I will just have to do is to multiply all the opposing forces. And the only opposing force here is R2. So 5 minus R2 will give us what? Will give us the force, that is the pull at this point. Here, it will be nothing but 55 R2. And of course, our 55 is kilonewton, which is 55,000 what I have here. Now, 55,000 minus R2, of course, from here, you can see that it's equal to R1. So this body or this section at equilibrium. So next, I'm going to be drawing my free body diagram for section N. N. Now, I have R2 upward. I have R2 going upward. What do I have here? I need to have the force. I have 55 kilonewton coming here, but don't forget that I also have R1 going upward. So to get the total compressive force coming on this bar N from the top, I need to take out R1. Here will be nothing but here will be nothing but 55,000. Nothing but 55,000 are what I have here. So this is my free body diagram for section 1 and 2. Already I know that my 4.5 meter as my length. What I have 1.2 meters. LM. So what will I do next? If you look at this diagram very well, we have here to be fixed and we have here to be fixed. That is, the total extension of this bar will be what? Will be 1.2 meters. Because from here, there's nothing here. and we are expecting this bar to expand up to this point. That is the total elongation that this bar will have will of course be 1.2 meter. Now don't forget that here we are having a tensile force here, we are also having a compressive force here. Now to get the total elongation which we have already here, it is equals to of course the elongation of this and the elongation of this. Bearing in mind that what this is compressive and this is tight. What I'm saying is this: we are having the total elongation the what? The 1.2 meter. Of course, 1.2 millimeter, we can convert this to meter by dividing by 1000 equal to 0.0012. No mistaking. So what I'm going to be having is my total extension will now be equal to, okay, this is total extension equal to this, the extension of this, and try to call here 1 and 2. So it is equals to the extension of 1 plus the extension of our second what we have. Now for the extension of the second section, we know that elongation or extension first section will be equal to P. Now P for this section is the pool, which is R1. You can decide to use R1, you can decide to use 5,500 R2. But for this case, let's use 5,500 minus R2 because P is simply R1. We have 5,500 minus R. So this is what we have. This is standing at P here. We are going to be multiplying P by what? By the length. What length are we having? We are having a length of what? Of 1.2 meters. Multiply this by 1.5 by, what do we have here? We are going to be having what? We are going to be having EA. Area for the first section is 110 millimeter square. Converting 110 millimeter square to meter, what are we going to be having? Having 110 times 10 to the power of what? Of minus 6. Multiplied by E, which is what? 200. E is nothing but 200 times 10 to the power of 9. This is what we have for the elongation of the first section. Now for the elongation of the second section, we are going to be having P. Now our pool, if you look at this diagram very well, for this second section, our pool will be what? Either R2 or 5,500 R1. So we can decide to use R2 here. If we use R2, we are going to have R2 multiplied by, what do we have next? We have our length. The length of section 2 is 2.4 meters. We have 2.4 meters. All over what? All over our area. Area of section 2 from the diagram here says 220 millimeters square. Converting 220 millimeters square to meter, of course, will give us 220 times 10 to the power of what? Of minus. Multiplying by E, what? Which is 200 times 10 to the power of 9. This is what we have. So the sum of this and this, of course, you know that will give us the total elongation, which is what? This. So if we equate this, we are going to have 0.0012 meters, 0.0001 equal to what? Equal to this. Now, don't forget that this bar here is compressive, so it will be minus. It implies that we're going to have 5,500 all over 1,000, that is 220 multiplied by 2 minus 6 times 10 to the power what we have minus this, because what we said is compressive. So we have R2 multiplied by 2.4 all over 220 times what? 10 to the power of minus 6 multiplied by 200. So we are just going to be solving what we have here. So I will clean this part have here, you can see that we can take the LCM, of course, from what we have here. Do not forget that here is, okay, this is for our first extension minus the second extension. Of course, we have 110 here, so here is 110. Now, what we are going to do here, we're going to be having 0.0012 equal to 5,000 minus R2 multiplied by 1.2. What we have, dividing by what? We have 1, 1, 0 times 10 to the power of minus 6 divided by 200. What we have here, we minusing what? We minusing 220 course times 10 to the power of what? Of minus 6 divided by what we are having. We are having R2 first times 2.4 all over 20. So we are having this equals to this. Now we can take the LCM, of course. We take the LCM of this and this, nothing but this. Because this can go into itself and this can also go into this. So to take the LCM of this, we are going to be having 0.0001 equal to 5,000. Now what do we have? We have this as our LCM. Having 220 times 10 to the power minus 200 times this is the lowest common multiple. So from here, this divided by this, of course, we will left with 2. This will cancel this. This will go into here 2 times. So this will be nothing but 2 into 5, 5, 5. What we just did is that we divided this by this. So multiply our answer by what is here. So this will be minus this divided by this. Of course, it's 1. 1 multiplied by R2 times 4. Same thing times 15. So we have minus R2. Just take the LCM of the denominator, that is this and this, to arrive at what I just got here. So next, what should I be doing? I will clear this bracket. If I do that, I will have 0.0012 is equal to what? 2 times 5, 1.2 times 2. Of course, it's nothing but what? 2.4. 2.4 times 50,500 1,002 minus, what do I have? Don't forget I have 1.2 multiplied by 2. 1.2 multiplied by 2, which is what? Which is 4 point, which is 2.4 rather. So 2.4 multiplied by R2, what will I have? I will have 2.4 minus 2.4 multiplied by 2 all over my denominator, which is 10 to the power of minus 6 to the power of 9. What do I do next? Minus 2.4 R2 minus 2.4 R2 is equal to minus 4.8 R2. So this equation will become 0.0001 is equal to 13,200 minus what? 4.8 all over power of minus 6 power of 9. So what I'm going to do next, I'll be cross multiplying. If I cross multiply, all right. So next I'm going to be cross multiplying. But you know that when we multiply, of course, when we multiply 4.2 times 2.4 rather times 55,000, we're going to be having 13,000. So we need 1 0 here. Press this is your calculator. It's going to give you 132,000, not 13,000. So do not make that mistake. Press it in your calculator to be sure you get the exact value. But this is the value we have. So next, I'm going to be cross multiplying. If I cross multiply, I'm going to be having 0.0012 times this 0 times power of minus 6, 200 times the power of 9 equal to what I have here, 1,000. This is 130,000, rather 4.5. This is what I have. Next, I'm going to be cleaning this side as we simplify further. Further. If I simplify further, what do I do? I'm going to be taking 150,000 to the other side of this equation. If I do that, I will be having minus 4.8 r left to be equal to 0.0012 times 20 times 10 to the power of minus 6 multiplied by 200 10 to the power of 9 minus 13,000. 32,000, 132,000 rather. Don't forget, I divide everything by minus 4. Now, of course, now if I do this, minus 4.8 is and R2 is equal to what? Now, all you just have to do is to multiply this, minus it from 132,000 and divide it by minus 4. That is nothing but 2,500. That's 16,500. Don't forget our unit is in Newton. Now, how do I get my second reaction? I have R2 to be equal to this. To get R1, don't forget that from the free body diagram we drew before, we said that R1 is equal to 5,000 Newton minus R2. R1 equal to 5,000. From the free body diagram we draw, we have established this. So it implies that to get R1, R1 will be equal to 5,000 minus 16,500. So if you press this in your calculator, R1 will be nothing but 8,500. Okay, so next, what are we going to be doing? The question says, find also the stresses in the bar. Find also the stresses in the bar. So let the stress for the first bar be denoted by sigma Lm. We are going to denote our stress for the first bar to be sigma Lm, which is equal to nothing but what? P all over area. Of course, we know this is the formula for stress. Now, for the first bar, what will be our magnitude? That is our force. For the first bar, what will be our force? If you check the previous diagram I drew, you will realize that I have R1 to be what? To be the magnitude of pull for the first section. That is this section. I have R1 to be the magnitude of pull, where I put 55 minus R2 here, which of course equals to R1. So our P here now for the first section will be nothing but what? R1. So this will be our P here for the first section, nothing but R1. You can check our previous thing we just did, that is our two-body diagram. If you understand this better. Our A now, how do we get our area? Of course, it has been given to us as 110 meters squared. But of course, we have 110 meters squared. Now we want our answers to be meters. What do? We are going to be dividing 110 by 1 million, of course. And it's the same thing as multiplying by 10 to the power of 9. Of course, the same thing. So what do we have here? We are going to be dividing this. So our R1 is what? 8,500. We have 8,500 divided by 110. Place this in your calculator. You are going to have your value. Now, what value are we going you are going to be having nothing but. So press this in your calculator. What are you going to have? You are going to have 350 to the power of 6 Newton per meter, because this is what we have. So what do we do next? We are going to be looking for the last stress of the second section, which is sigma m. So I'm going to wipe this place. This is what we have. We have sigma m equals to the c equal to p over what? E. But don't forget, now we are considering what? We are considering this section. Okay? So if we are considering this section, earlier on we drew the free body diagram and the we have the pool R2. So our magnitude of pool here is what? Is R2. All over the area. The area of this second section is given from the question is 220 millimeter square. Converting 220 millimeter square, we divide by what? By 1. The same thing as saying 220 and 10 to the power. Now, if you press your calculator, okay, we have R2 first, the what? 16,500 all over 0 times 10 to the power minus. Press your calculator, having nothing but 75 times 10 to the power of 6 newton per meter. 75 what we have as our stress for the first section, is our stress for the second section, and of course our reactions for the upper support and the reaction for the lower support. Thank you for watching. Be sure to subscribe to our YouTube channel if you find this video helpful, and also share the video for those who might be